Here we go. We have a question palindrome linked list. So you have given a single linked list of integer and our task is to check if the given linked list is palindrome or not. So we have this linked list and this is the representation. So it is clearly visible that the string is palindrome. The list is palindrome. And in this case the list is not palindrome. So we have to return false. So let's build the approach. So I have taken two linked lists. One is of the length odd and one is of length even. So in this question we gonna apply slow and fast pointer. Slow initially, slow and fast pointer points to the head node. So slow will point to one step ahead and fast will take two steps. Then slow will take one step, fast will take two steps. Now fast cannot take two steps, so we stop here. Same applies for this. Slow and fast point to the head node. Slow takes one step, fast take two steps. Slow takes one step, fast take two steps. Slow take one step and fast takes two steps. So after we stop this iteration, we gonna need one another pointer which is previous. So previous will point to the previous node of the slow pointer. So previous in this case points here and in this case previous points to this node. So before jumping to the next node, before we initialize the slow to the next node, we first initialize previous to the current slow node. So just for example, in this case previous is null and slow and fast points here. So we gonna take a step forward. So before that we have to point previous to the slow node. Now slow takes one step, fast take two steps. Then we gonna need one more step ahead. So before that previous will point to the slow node, then slow takes one step, fast take two steps. Then previous will point to the slow node and slow will take one step and fast will take two steps. So that's how previous will point to this node and in this case previous will point to this node. So after we are done with this, we need to disconnect the link. So we disconnect this link, then as you can see slow is pointing to this node and in this case slow is pointing to this node. So we have two separate linked lists. Then we need to reverse this linked list. I hope you already know how to reverse a linked list. If you don't know, a link is given in the I button, so be sure to check that video first, then come to this video. So if I reverse this linked list, it will look like this. First we have 1, then we have 2, then we have 3. But as you can see here, before this we have this. So this is a odd length, means there's a middle node. So we don't need to check 3 to itself. A single node is already a palindrome. So we just need these two nodes. So if our fast node is not null, means the length is odd. If the fast node is not null, means we have odd length. So we just need to take one step ahead and now slow will point to this node. We don't need the middle node. So we will just reverse this list. So we have this 1 and 2. 1 and 2 only, and we don't need any other list, and slow is pointing to this node. So same applies here. Fast is already point to the null node, so we just need to reverse this list. So it will look like this: 1, 2 and 3. So slow is pointing to this node. In this case, slow is pointing to this node. So we have two separate linked lists. One is this and one is this. So we just need to traverse, and if at any point the value is not equal, we will return false. Else, if all values are similar, at the end we will return true. So uh, slow is pointing to this node, fast is pointing to this node, this and this value is equal. So fast will take one step, slow will take one step. This value is also equal, fast will take one step, slow will take one step. Now both values null, so this linked list is palindrome. Same applies here, slow points to this node, fast point to this node, this value is equal, then move ahead, this value is also equal, move ahead, this value is also equal, move ahead. Now the pointers are point to null node. So the linked list is palindrome. So that's how this approach will work. Let's code this. Slow and fast initially pointing to the head node, and previous points to the head node, or you can uh, initialize it with null. So while this condition holds, fast will take two steps, and before initializing our slow node, we have to first point previous to the current slow node, then slow will take one step. So this is just a variable. So previous dot next. So this is the thing that disconnect the linked list. So now we have two separate linked list. If fast is not null, means the length is odd. So we need the reversal starting from slow next node. If fast is null, we just reverse the linked list. So after reversing the half of the linked list, this is the reversal function. So this is the reversal function using recursion. So now A point to the head node and B point to the second half of the linked list that we just disconnected. So if A not equal to B, means the value must be same and B is also not null. If the data is not equal, just return false. A will take one step, B will take one step. If all values are equal, answer is true. So let's submit this, and let's talk about time and space complexity. So first we are iterating, then we are again iterating, and here we are again iterating. So the overall time complexity is order of n, and space is constant. So we have met the expected time and space complexity. Here it is given, you should not use the recursive stack space as well. So here we are using recursive stack space, but you can optimize it using iterative manner. So if you want to know how to reverse a linked list using a for loop, a video link is given in the I button. So be sure to check that video also. And if you like this video, give it a thumbs up and subscribe to this channel. Code is given in the description box. Thank you all for watching.